Okay. Now, I did some kind of unfortunate, because some of you have A values that are 4, but that's actually fortunate in a way, so we'll look at that, okay? Because it illustrates one of the important things. And I'm gonna do it with an A value other than 4, so I'm gonna do this with supposed to be out of line. Okay. Now, if you write this out as equations, you know that you're going to do -3 times this plus this. Because that's what everybody that had equations did. Okay. Make that a little easier, and to get this thing into this form, which is what we're trying to do. Go to write the equations in the opposite order. Same two equations, it doesn't matter which one's first and which one's second. You can still do -3 times this and add it to this. Okay. So I'm going to say, okay, first of all, keep a track of what I've done. This is my old row 2, and this is my old row 1. Okay. Then I'm going to do, and row 2 is just the way I want it at this stage. Why? Because what I'm after is a 1 here. So it's convenient that by switching these, I got a 1. Once you have a 1 here, you can wipe out everything below it. Now, there's only 2 equations, so no, there's only one thing below it. If I had 3 equations and 3 unknowns, I can do the same thing again. You're going to jail. Doggone you. And every time I see you again, you're taking another month in the hoosie. Okay? Okay. Just wait. We'll make the law retroactive. Okay. Teach him a lesson. It's got the skills to do it, honestly, doesn't have to lead me to porn sites, does it? Okay. Anyhow, okay, there we go. Yes. Okay, then what I want to do is I want to do my row 2 -3 times row 1. Okay. And this means, this is my, I'm confusing myself. This is my old row 1. Okay. I wrote a 2 because it was 2 up here. But now it's row 1 because whatever I put in a circle here is my old row 1. Okay. So it used to be my old row 2, but now it's my old row 1. Okay, so there it is. So I want to do row 2 -3 times row 1. And that's pretty easy. All I do is I do -3 times the number here and add it to the number here. So -3 times 1 is, that you're going to tell me it's -3. When I add that to 3, I'm going to get 0, which is equivalent to eliminating my x. Now that's what everybody pretty much did. You eliminated your x when you did the equation. This is just shorthand for what you already have done. Okay. So I'm going to get a 0 here. And then I have to do the same thing. So I got to do -3 times the entire first row. I've got to multiply everything in the first row by -3. And then it's 2 added to that. In other words, the number in row 2 is added to -3 times the number in row 1. Well, -3 times 6 is, do it in your head, got it? It's -18. And add that to 12, I get -6. And then -3 times 7 is -21, added to -11 gives me -33. Fair enough? Okay, so I've made progress. I've got my 1 here and my 0 here. Okay. Well, now, what do I need? I need a 1 here. Now, I could actually do a little bit of a shortcut since these numbers match up so conveniently. I could add this row to this row and get a 0 here, right? But generally, that's not going to work. So I'm not going to do it. I'm going to just go methodical. I'm going to get my 1 here, and I'm going to get my 0 here. Then I'm going to get my 1 here, and I'm going to get my 0 here. So I've got my 1 here and my 0 here. I want a 1 here. So what I do is I don't change row 1, still 1, 6, 7. My row 2. I divide row 2 by -6. Means I divide every number in row 2 by -6. So if I divide -6 by -6, I get 1. That's what I was after. But I've also, of course, got to multiply or divide my -33 by -6. And that's, well, it's -33 over 6. It's actually reduces, that actually reduces down to -11 over 2. Okay. So I'm going to replace that by -11 over 2. Since I'm dealing with fractions, I want to deal with the smallest numbers I can. And I've got a question here that I better answer. I'm in even more trouble than I already am. Okay, hang on. Now people are picking on me. It was obvious that I hadn't switched these numbers when I switched up. Yeah, my second row was 1, 6, -11. There should be a -11 there, right? And my first row was 3, 12, 7. 7 goes with the 3, 12. Let me go through all those steps. And it was working out so nicely. Actually, it's pretty easy to correct at this point. It was getting, I was going to get something wrong. Okay, so let's see, 1, 6, -11. So, okay. Except it's not saying here, it's -7 over 6. And then I got to get a 0 here. Got barely enough room. I apologize. I'll leave myself a little more room out here. I'm still going to have my 0, 1, -7, 6. And this just stands for y equals -7, 6, right? Okay. And that's what we would get if we wrote out the equations and did same operations I'm doing here. Okay. Now I'm going to do row 1. -6 times row 2. And we're going to keep row 2 here because row 2 is exactly what I want. This asterisk now is my -7, 6. Again, it's my value of y. Okay. In the first row, whatever multiple of row 2 I add to row 1 is not going to affect this 1 because I've got a 0 here. And then if I do -6 times this and add to this, I get -6 and 6, which gives me 0. And then -6 times this gives me 7, which I add to my -11, which gives me 4. So just coincidentally, I didn't plan it. Just pick random numbers. I get x equals 4, y equals negative 7/6. Okay, so my original equation was that's right. Down here, well, this just switches my two equations. Here, this stands for x equals 6y equals negative 11, same as it was. This stands for negative 6y equals 7. Okay. Again, if you had the equation, it'd be convenient just to add this equation to this one, and you'd have a solution for x, but that doesn't usually happen. So we're going to continue as we did here. This equation stands for this. Okay. And then this equation stands for x. And I'm, really solving this, solve it earlier, because I don't mind if I have a mistake. Okay. Now I do mind that I make as many mistakes as I do, but there could be a mistake, and that leads me to the conclusion that I better check these in the original equations. Now, if x is 4, that gives me 3x is 12, and then negative 7/6 times 12 is negative 14. Uh-oh. That seemed to work. This means I made an arithmetic mistake. Apparently. Okay, so where's my arithmetic mistake? Yeah, I'm not seeing it. But apparently it was a mistake. I've got to go back. And at this point, I probably want to go back and do it by scratch. Uh-oh. I'm going to get corrected. Okay. Well, it looks like I was careless. 2 minus 3 times equation 1. I need to do equation 2 minus 3 times this. Well, minus 3 times 6 is negative 18. And here, equation 2 minus 3 times 3. Pretend I didn't just do that. Okay, so this is equation 2 minus 3 times equation 1, which appears that I did completely wrong. Because I do minus 3 times this and add it to 3, I get 0. I do minus 3 times this. Oh, that's right. I add it to this and I get negative 6. Okay, that was right. But I never did minus 3 times this added to this, did I? Minus 3 times negative 11 is negative 33. Add that to 7, I get negative 26. I should have been more suspicious when I got a whole number here, but let's go on. Okay, let's check that out again. That's not minus 26. It's negative 3 times that's 33, and 7 gives me 40. Always pays to take a second look so you can make a different mistake. Okay, so I got 40 here. Double check that again. Negative 3 times 11 is 33. 33 and 7 is 40. Okay. Then when I divide this by 6, I get negative 40 over 6, which reduces to negative 20 over 3. Then I do minus 6 times this added to this. Minus 6 times negative 20 over 3 is plus 40. It should be 29. At this point, I want to check it out with the equation. I'm going to get negative 80 and plus 87, that gives me 7, that works. And then I'm going to get negative 40 and 29 gives me negative 11, and that checks. So that my equations over here okay, this is negative 6y plus 40. This will be, we'll still have the negative 11 here. This will give me y equals negative 20 over 3. And then this gives me x equals 29. Y equals negative 26. And it checks. Okay, so finally we've got a good solution. Be more careful than I am. Okay. Do we understand how the operations here could be applied to the equations equally well? In other words, what would I do here? I do this equation minus 3 times this equation. Actually, okay. After switching the equations, I do this equation minus 3 times this. Which gives me this equation. My result is good. Okay. So again, minus 3 times this plus this gives me this equation. Now, the difference between what I'm doing here and what you're doing when you write out these equations is you're not necessarily writing out 2 equations every time. Okay. If you do, you see more clearly how everything corresponds to what we're doing. Another thing that happened on some people's numbers, some people have 4 or A. Okay, let's see what happens if A is 4. Here we have 3, 12, 7, 1, 4. We'll use negative 11. So we switch the row. Carefully. And then we add 3 times this to this. That gives us 1, 4, -11. So I'm using the same operation that I did down here. If I do row 2 minus 3 times row 1, then I'm going to do 3 minus 3 times 1, which gives me 0. And that's, of course, why I do that. I get the 0. Okay. Then I've got to do this minus 3 times this. 12 minus 3 times 4. What's that give you? Again, 12 minus 3 times 4. Gives a 0. Okay. -3 times 4 is -12. 12 minus 12 is 0. So it gives us a 0 here. And then, of course, it gives us the 40. What's wrong with this? Well, there's really nothing wrong with it. What this tells us is first of all, it tells us that x plus 4y is -11. And it tells us that 0x plus 0y equals 40. But what's 0x plus 0y? It's 0 because it doesn't matter what x and y are, any number you multiply by 0 is 0, and when you add zeros, you get 0. Happy so, there's no solution to these equations. Why is that? Well, if you were to graph these equations, you'd have parallel lines with no intersection. Might be a little hard to read that. That's a parallel line, no intersection. Okay. Remember, and it says when two equations of two unknowns can be graphed very easily. And had you graphed it, it would have looked like this. You would have suspected that they don't intersect. And then how would you know for sure that they don't intersect? You'd find their slopes. They have the same slopes with different intercepts. Okay, so that can happen, and it did happen to some people. So I thought I was making things easier here. Well, that caused a little bit of confusion, but then I was like, use that example, show you that you don't always get a solution. Okay. Okay. So we can multiply row by any number. And I believe Open Math has told you this, okay? Just like we can multiply an equation by any number because a row stands for an equation. We can multiply the whole equation, both sides, by the same number. And it doesn't change its solution. Okay, so we can add. any multiple is one row, another. And we can switch rows without affecting our solutions. It's like writing the equations in a different order. But if you got two equations, they have graphs. If you graph the two equations, you can't tell which one was first and which one was second. So the order doesn't make any difference. The order in which you write the equations makes no difference to the solution. So it's often convenient to switch rows, as it was here. We switched rows because that gave us a one here right away. Okay. Well, I'm going to do a system of three equations and three unknowns. And I'm just going to do a 3x3 matrix, so we don't have to worry about the arithmetic of that augmented part. I seem to keep screwing up today. Okay. So let's just take this. Okay. Now let's talk about this a little bit. You see any way we might want to change the order of the rows to make the numbers a little simpler? Okay, so here's my matrix. Not sure I said on camera. I could get a one here right away because my goal is to get this matrix if possible. If I divide through by 7, I get 1, 3 sevens, 19 sevens. I've got my one. But now I've got fractions that I'd maybe rather not deal with. So it might be a good idea. I mean, it'd be possible to go ahead and reduce based on what I did there. So it might be easier to do that. But just to make it a little prettier, I'm going to switch the first and second row. It doesn't take long to write it down. And I'm also definitely not going to switch the order of the third row because I got a 0 right where I'm going to want it. I've got this 0 already. I'm not going to do anything to mess that up. So this is my old row 2, this is my old row 1, and this is my old row 3, which stays where it is. Then what do? I divide this row by 2. Right. Okay, so there's a 2 there, and I want to write it 2. I think I've done that consistently. But this is my old row 1. This is my old row 1 divided by 2. And then this is now my old row 2. This is now my old row 3. Next, I can just add 7. Okay, I can do this minus 7 times this is going to give me 0, right? So I do all of row 2 minus 7 times all of row 1. Not going to mess with my old row 1 because I've got the 1 right where I want it. I'm going to do second row minus 7 times the first. If I had a number other than 0 here, I'd go ahead and do an operation to get a zero, okay? Just having a one here allows me to wipe out all the numbers below it very easily. In this case, I'm not going to have to do that. Okay, so my row one is still the same as it was. I take my row two, my old row two, and subtract 7 times row one. So I do 7 minus 7 times this. That's going to give me 0. And then I think of, well, I'm going to multiply every number in row one by minus 7 and add it to the number in the second row. So minus 7 times 1 added to 7 gives me the 0. Minus 7 times 3 is negative 21. Add that to 3 and I get 18. Negative 7 times 4 is negative 28, which I add to 19 and I get 9. Got 0, 5, 7. Well, let's write that up here now. Okay, now I'm just going to multiply my second row by 1/18. That's going to give me a 1 here because, okay, what I've got? I've got my 1, 0, 0 column. Now I want to get a 1 here. And then I'm going to want to get a 0 here, but I want to get this 1 first. Because once I've got a 1 here, it's going to make it easy to get a 0 here and here. Okay, so got 1, 3, 4. And then I've got row 2. Divided by 18, that's 0, 1, 1/2. 18 over 18 is 1, 9 over 18 is 1/2. And my row 1 and row 3 are unchanged. But in the next step, I can get rid of this 5 easily. Okay, looks like I've done something else. So I'm glad somebody's watching. Okay, what is this? 2 minus 7 times 1. Minus 7 times 3 is negative 21. Here, 7 times 3 is negative. Yeah, negative 21 added to 3 gives me negative 18. I did 20. I did it. Okay, anyhow, then we get negative 18 here. And then we're going to divide by negative 18. A little hard to read that, but that's what we did. Then we get negative 18 over 18 is 1, negative 18. Negative 9 over 18 is negative 1/2. Okay. Next thing we're going to do is going to wipe out this 5. And we do that by doing row 3. Minus 5 times row 2. Make sense? So do this minus 5 times this, I'm going to get 0. So let's just do that. We're going to do this. Negative 5 times 1 is negative 5 added to 5. Yep, that gives us 0. Negative 5 times negative 1/2 is positive 5/2. 7 is 14/2. That's 19/2. Okay. Second row, I'm not going to mess with. But the first row, I can do the first row minus 3 times a second and get rid of this 3, make this 3 into 0 because that's going to accomplish this. So again, you see that once I have a one here, anything above and below it is easy to make into a zero. Of course, we've got to do that by valid operations. So we do row one minus 3 times row two. That gives us 1, 0 is 3. Well, 3 times 0 is, well, let's see, negative 3 times 0 is 0. Add it to 1, we get 1. Negative 3 times 1 is negative 3. Add that to 3, we get 0. Negative 3 times negative 1/2 is positive 3/2. Add that to 4, which is 8/2, and we get. Okay. Now we're almost on 3 because we just got to get a 1 there. What operation is going to give us a 1 here? Think about it. I multiply row 3 by the reciprocal of this fraction. Well, 2/19 times 19/2 is 1. Okay. Then I'm still going to have 11/2. Negative 1/2, because I'm going to save the final operations. Now, if I simply take row 2 and add it to 1/2 of row 1, 1/2 of this plus this gives me 0. And getting bunched up here a little bit, you might find it hard to read. But all I'm doing to row 2 is I do row 2 plus 1/2 of row 3. So here's row 2, here's row 3. I've got zeros here, so I'm going to have a 0 and a 1. And when I add 1/2 of this to this, I get 0. Of course, I've got my third row, which isn't going to change. And my first row is then going to be 1, 0. And this is one that's probably a little hard to read. It's row 1 minus 11/2 of row 3. I'll write that out a little more clearly. What it says here, but it's a little hard to read. Okay. And if I do that, well, negative 11/2 times 1 is negative 11/2. I add that to 11/2. I get 0. And there it is. Okay. So it's not that difficult a process. It's the same operations we looked at earlier. But it works out. Now, if we have 3 equations and 3 unknowns, then we're going to have another column over here. But the operations we use to reduce 3 by 3 matrix are going to be exactly the same. And whatever numbers are in that 4th column, those will be like the numbers on the other side of the equal sign in our equations. We'll just go along for the ride. And since we've got some fractions here, fractions aren't too bad. They're mostly just halves and stuff like that. Okay. Now, those numbers go along for the ride and we'll end up with X equals this number, Y equals this number, Z equals this number. Okay. So that should be fairly straightforward. So I've extended, because some people got through the thing on the matrices just fine, but you know, But looking at your work, everybody needs a little bit more practice. So I've extended the assignment till next time. For practice, it wouldn't hurt you to go to the late assignments page and work the problems there, which will have slightly different numbers, but with the same operations, because practice is going to help. Okay, so where we are in the course right now is this assignment matrices is the last one, which gives us 3 days to review, which means hopefully do a good review. Everybody comes out with a good grade on the final and a good grade for the course. Okay, so everybody's doing okay in the course now. And again, been impressed with what you are doing. Stay at it. Keep your nose to the grindstone for 3 more weeks. And I think you're going to be happy with the result. So, got a question? Let me